Good morning, I am Dr. Rambabu. In this session, I am going to discuss about data communications. Short distance data communication, long distance data communication, the components of data communication, the characteristics of data communication, and the information flow in the data communications. These are the important points we are going to discuss in this session. We know the communications made the world small. There are two types of signals which are used in the communication. They are analog signal and digital signal. The analog signal is the continuous signal. You can see how the signal goes in this diagram. In the analog signals, some characteristic like amplitude, frequency or phase of the signal changes with the time. The other type of signal is the digital signal. The digital signals can have the values either 1 or 0. The signal may be present or may not be present at a particular time. You can see in this diagram, the presence of signal is represented by 1 and absence of signal is represented by 0. The contents which we are going to discuss in this session are data communication, components of data communication, data representation and data flow. When we are communicating, we are sharing the information. This sharing can be a local or remote. Between individuals, the local communication usually occur face to face or between the devices in a particular room or in a campus, while remote communication takes place over long distances. Let us see the definitions of some terminology over here. The term telecommunication means the communication at a distance. The term data refers to information presented in whatever the form is agreed upon by the parties creating and using the data. Data communications are the exchange of data between the two devices via some form of transmission medium such as a wire or air. Data communication between remote parties can be achieved through a process called networking, involving the connection of computers, media and networking devices. In the broad sense, we can classify the data communications in two types, that is short distance communication and long distance communication. The short distance communication is local communication and long distance communication we call this as a remote communication. Now let us see some characteristics of the effective data communication. The effectiveness of the data communication system depends on four fundamental characteristics. They are delivery, accuracy, timeliness and jitter. Delivery. The communication system must deliver the data to the intended receiver and the data must be able to be received by the intended receiver only. Second characteristic is the accuracy. The system must deliver the data accurately to the receiver. Timeliness. Timely delivery of data is very important. The data received late will not be of any use in some applications like real-time systems. Especially in audio and video data communication, the data must be delivered in the same sequence as it is generated without much delay. The fourth characteristic is the jitter. It is the uneven time in the arrival of the data packets. It must be as low as possible, especially in audio and video communications. Now let us see the components of data communication system. In this diagram you can see the components. The sender and receivers are must for any communication, and there should be some information or data to be transmitted, that is what we call here as a message, and there should be some communication media. The communication media can be a guided medium or a electromagnetic spectrum, and apart from that we have protocols. In this diagram you can see the data communication using guided media. So this is the guided media. Here you can see the sender is there, receiver is there, message is there, protocols are there. The media is here an unguided media, that is electromagnetic spectrum. The components of communication are message, sender, receiver, transmission media and protocol. The message, it is the information to be communicated. It can be in the form of text, numbers, pictures, audio and video. The sender is a device that sends the message. It can be a computer, workstation, telephone handset, video camera and so on. Similarly, the receiver is a device that receives the message. It can be again a computer, workstation, telephone handset, video camera, like that. Next component is the transmission medium. The transmission medium is the physical path by which a message travels from sender to the receiver. It can be guided, it can be unguided media. Some of the examples of the media are twisted wire pair, coaxial cable, fiber optic cable, these are the guided media, and radio waves, this is unguided media. And next component is the protocol. The protocol is a set of rules or guidelines that governs the data communication. Now we will see how the data representation happens in the data communications. Information today comes in different forms such as text, numbers, images, audio and video. In data communication, the text is represented as a bit pattern, a sequence of bits, zeros and ones. Different sets of bit patterns have been designed to represent the text symbols. Each set is called a code, and the process of representing symbols is called coding. Today, the popularly used or prevalent coding system is called Unicode, which uses 32 bits to represent a symbol or a character, which can be of any language in the world. The American Standard Code for Information Interchange, that is ASCII, has been developed in USA long back. The next form of the data is numbers. The numbers also are represented by the bit patterns in the data communications, but however, a code such as ASCII is not used to represent the numbers. The number is directly converted to a binary number to simplify the mathematical operations. The other form of data is images. Images also represented by bit patterns. In its simplest form, an image is composed of a matrix of pixels, that is pixel elements. It is a small dot. After an image is divided into pixels, each pixel is assigned a bit pattern. The size and value of the pattern depends on the image and the resolution what we want to transmit. For an image of only black and white dots, a 1 bit pattern is enough to represent a pixel. For grayscale, it is different. If image is not made of pure white and pure black pixels, you can increase the size of the bit pattern to include grayscale. For example, to show 4 levels of the grayscale, you can use 2 bit pattern. A black pixel can be represented by 00, a dark gray pixel by 01, light gray pixel by 10 and the white pixel by 11. To represent the color image, there are different methods. One method is called the RGB method because it uses 3 primary colors, red, green and blue. How it is represented using the color images is out of the scope of our communication. That part we may be able to see in the image processing. The another form of the data, that is audio. Audio refers to the recording or broadcasting of sound or music. Audio is by nature different from text, numbers or images. It is a continuous and not discrete. Some characteristics of the signal like amplitude will change with the time. Next format of the data is the video format. Video refers to the recording or broadcasting of picture or movie. Video can either be produced as a TV by a TV camera. The important aspect in the data communication is the data flow, how the data flows. The communication between two devices can be a simplex, half duplex or a full duplex. In simplex communication, the data flow is in only one direction. Here in this, A is the transmitter, sender, and B is the receiver. the data always flows in only one direction, from A to B. Some examples of the simplex communications are like radio transmitter and a radio receiver. Transmitter always transmit, the receiver only can receive. And a television system. And the communication between the keyboard and computer is also a simplex. Keyboard gives the signal and computer takes it. The communication is one way. Between the computers also we can have simplex communication, especially from the mainframes to dummy terminals. The communication is simplex. Here we can see the mainframe to monitor. Monitor is the dummy terminal. The communication is simplex. Another type of data flow is half duplex. The half duplex supports two-way communication, but one at a time. You can see in this diagram the sender and receiver. Both the stations can send and receive the signals, but one at a time. Here at the time 1, if this station is sending, at the time 2, this station can transmit. You can see here the illustration of half duplex communication. There is a communication between A and B. A also can transmit, B also can transmit, but both cannot transmit simultaneously. One at a time they can transmit. This is the concept of half duplex communication. The half duplex communication can also happen between the two computers. Here A is sending and B is receiving. At the second instance of time, the B is sending and A is receiving. One of the best examples for this half duplex communication is the walkie-talkie communication. Here walkie-talkie number 1 is transmitting and 2 is in the receiving mode. Here the 2 is in the sending mode and 1 is in the receiving mode. This is half duplex communication. And long distance communication can also be half duplex. With the modems, you can see here sender, this modem is transmitting and this modem is receiving. And similarly, when this receiver transmits, there is no communication from this machine. Another example for this half duplex communication is request and reply systems, or request and response systems. So one can see over here in the satellite communication, here the PC or user can make a request through internet service provider, some information, and satellite can respond. This is the uplink and this is the downlink. So request and response happens at two different times. So this is a half duplex communication. In the computer network also we can have the half duplex communication. Say for example, the star network, if you are connecting through hub, between the machine and hub, the communication is half duplex. Here you can see the communication is half duplex. Now let us see the full duplex, how it works. In the full duplex, the communication can happen in both the directions between the two communicating stations simultaneously. Here you can see both A and B are communicating simultaneously. This is a full duplex communication. Some of the examples for a full duplex communication are the telephone. The telephone is the full duplex. Between the computer to computer communication, we can have the full duplex communication. In the computer networking also, we can have the full duplex communication, especially in the star network. When you are using switch to connect the machines, the communication between the switch and the machines is the full duplex communication. To summarize, in this session, we have seen the basic principles of data communications. We understood the communication made the world small, and data communication uses the bit representation. The data can be available in different formats like text, numbers, audio and video, images, but in the data communication, whatever may be the input form, that will be converted into ones and zeros, a bit pattern. Then we have seen the characteristics of data communication and the data flow in the data communication, like simplex, half duplex and full duplex systems. Thank you.